Welcome to Definite Integrals Part 1, Lesson 1, the Fundamental Theorem of Calculus, where we talk about finding the area under a curve. So let's get right at it. Find the area of the shaded rectangle. And I know from your middle school and geometry classes that you could just do area equals base times height. The base of that rectangle is 7, and the height is 3. So I realized that you could just find the area equals 21 units squared. Let's do that using some calculus. We are going to find the area underneath this curve right here. So we need to know what that function is. That function is y equals 3, right? And we're integrating from -2 to 5. So the integral from -2 to 5 of f of x, which is 3, if y equals 3, f of x equals 3. So 3 dx, and then that would be the antiderivative of 3x is, the antiderivative of 3 is 3x, and we're going to evaluate that at 5 and -2. So that would be 3 times 5, it's a new little symbol here, minus 3 times -2. And that's how you will evaluate those. 15 minus a -6, 21. Let's do another one. Okay, the area of that triangle, what you learned in geometry or in middle school, area equals 1/2 the base times the height. Area equals, 1/2. The base is 6. The height is 6. The area equals 1/2 of 36. The area is 18 units squared. Let's do this with some calculus. Okay, this right here is the curve under which we are integrating. What is the f of x there? What is the function? That function is y equals x. That's just the line y equals x. So we are integrating from 0 to 6 of x dx. Okay, the antiderivative is x squared over 2, and we're evaluating that at 6 and 0. So 6 squared over 2 minus 0 squared over 2, 36 over 2, 18 units squared. Alright, let's go ahead and move on. Go ahead and copy this down, and then I might do a little bit of talking about it. Alright, so go ahead and just copy that down. Alright, I will move it up a little bit more. I'm not sure if my head's in the way of the bottom there, but I will go ahead and stop and get the top part of 2, and then I'll move it up. Alright, there you go. Should be able to see it now. These two concepts should lead us to the fundamental theorem of calculus. Here it comes, the fundamental theorem of calculus. Alright, you got it? Good. You need to pause it, go ahead, because I'm moving along. Here we are. Okay. The antiderivative for 1/2 of x minus 3 is x squared over 4 minus 3x evaluated at 6 and 0. So 6 squared over 4 minus 3 times 6 minus 0 squared over 4 minus 3 times 0. So we have 9 minus 18. The answer is -9. There you go. Well, that's the answer. That's the area underneath the curve. Moving right along. Alright, from 0 to 12. 1/2 x minus 3 dx. Again, the antiderivative. X squared over 4 minus 3x. Evaluated at 12 and 0. Okay. 12 squared minus, 12 squared over 4 minus 3 times 12 minus 0 squared over 4 minus 3 times 0. 12 squared is 144. 36 minus 36. That definite integral is evaluated at 0. Alright, hey look, the bounds are switched. X squared over 4 minus 3x evaluated at 0 and 6. I know we could switch it around, but we don't need to if we don't want to. This one, let's just evaluate it the way it is. Alright, let's see here. That would be 0 squared over 4 minus 3 times 0 minus 6 squared over 4 minus 3 times 6. So you've got 0 minus 9 minus 18. 0 minus a -9. This is 9. Notice that it is the opposite answer from 0 to 6, which was -9. This is +9 because the bounds are backwards. It looks like the second point I gave you right before the fundamental theorem of calculus. Alright. A of x equals pi, from pi to x, sine t dt. What is a of 2 pi? Well, that would be the integral from pi to 2 pi of sine t dt. What is the antiderivative of sine t? That's right, it's a negative cosine t evaluated at pi and 2 pi. Alright, so cosine of 2 pi, so cosine of 2 pi is 1, so that would be -1. Subtract. Okay, cosine of pi is -1, but this is a negative, so that would be 1. So that would be -2. You thought it was going to be harder than that. No, not at all. How about a of 0? Okay, that would be the integral from pi to 0 of sine t dt. Again, the antiderivative is cosine of t, evaluated at 0 and pi. Cosine of 0 is 1, so negative 1. Subtract. Cosine of pi is negative 1, so subtract, and that would be negative of the opposite of negative 1, which would be 1. Again, that is, the answer is negative 2. Let's try one more. What is a of 17? Okay, that would be the integral from pi to 17 sine t dt. So that would be negative cosine of t evaluated at 17 and at pi. And of course, I do not have that memorized, so I had to pause it and look it up. And so let's see here. The negative cosine of 17 is 0.27516. Subtract the negative cosine of negative pi, which is the opposite of negative 1. So my final answer is negative 0.72484. And that is that. That's that definite integral. This does conclude Definite Integrals Part 1, Lesson 1, the Fundamental Theorem of Calculus.